So now this video discusses about the electron configuration using Spdf notation. So what is the electron configuration using the Spdf notation is all about? We should have to understand that using KLMN notation, let's say this is the atomic structure, this is the center, which is the nucleus, this is the first shell, this is the second shell, which is the energy level as well. Let's say this is the third energy level, which is said to be the third shell. Now in these shells we also have what we call them as subshells, where electrons specifically are found. And for the sake of interest, in the actually first energy level there is a subshell known as subshell S. And in the second energy level we have two actually subshells. We have subshell S as well as the subshell P. And in the third energy level we have subshell S, B as well as the D. In the fourth energy level we have subshell S, we have B, D as well as the F. Likewise subshell 5, likewise in energy level 5 we have subshells S, B, D, F as well. So that's how you start to understand about the subshells. We have actually subshells in form of Spdf. Now each subshell has the maximum number of electrons it must have to accommodate. And for instance, any sort of a subshell must have 2 electrons. So any subshell S must have to occupy 2 electrons. And while subshell P must have 6 electrons, subshell D must have 10 electrons, and a subshell F must have 14 electrons. And of course subshells can keep on actually going up to whatever, but for the sake of interest we just have to stop at subshell F. So how can you be able to use the Spdf notation to actually have the electron configuration, if that is the case? So what is the order of configuration using Spdf notation? So the order of configuration follows the direction of the arrows. And for this case, starting from the tail of this arrow, we are going down. So which means this is the first subshell, that is given as 1s2. And then we'll move up and enter through this actual arrow, and I'll have 2s2 subshell, and from there I'll also enter again like that, where I'll have it as 2b6, and I'll also have what we call it as 3s2, and from there I'll also enter again here. We have it as 3p6, and we have 4s2. So by the way, we do not read this one as 2s square, but we just have to read at it. We just have to literally actually read the way you have to. Let's say 2s2, 2b6, but not 2b6 actually 2b to the power 6, no. And from there we'll have to go back again and enter here. We have it as 3d10 and 4b6. We have 5s2, and also enter again here, where we can have it as 4d10 and 5p6, and that is being given as 4s2. Should be 6s2, 6s2, like that. So you have 6s2, and what else should we have to think about? And also enter again here, where we can have 4f14. You have 5d10, you have 5b6, and there should be should we say 5 should be that of, we are from 4F14, 5D10, and 6P6 should be that. We can have it as 6P6. So 6P6, like that. And I'll have 5S2, and also enter again up to that point, and also enter again up to that point, and also enter again up to that point. So that is the order of configuration. So what it does is that we have the general order which is given us. So make sure you understand this particular diagram, because it gives you a clue on how you should have to move up on the configuration using the Spdf notation. And so we have the order which is given as 1S2, we have 2S2, we have 2P6, 3S2, 3P6, let's say 4S2, we have 3D10, let's say 4P6, we have 5S2, we have 4D10, we have 5P6, we have 6S2, we have 4F14, and the 5D10. They also have 6P6, like that, and we have 7S2. Of course the order is still going. I've just got it like that. So which means the electrons actually occupies 1S2, then after 1S2 they occupies 2S2. In other words, electrons do not occupy 3P6 before they occupy 3S2. Electrons do not occupy 4F14 before they occupy 4D10. So that's the principle behind the order of the electron configuration using what we call as the Spdf notation. And let us see how we can have the electron configuration and for the following elements. Let's say if we have the calcium, which is given us, let's say, whose atomic number is given us, let's say 20. So in that case we have 1s2, so have 1s2, and we'll also have 2s2. We are following this order, by the way. We have 2s2, so which means we have, should be that of, 4 electrons, so which means we are remaining with 16 electrons. So we have 2p6, now we are having 10 electrons. Then now we can have 3s2, we are having 8 electrons. We have 3p6, we are now remaining with the 2 electrons. Then we have 4s2. So this is the electron configuration for the calcium using that of the Spdf notation. So which means, let's say if we have been given the electron configuration using Spdf notation, you can be able to actually find the number of electrons that particular element is having upon having the summation of this, where from there you can be able to tell what is that element is all about. And what if, let's say, we have element like, should be, let's say, if we have the elements like magnesium. So what will be the configuration for magnesium, whose atomic number is 12? So principle remains the same. We'll have 1s2, we are having 10, 2s2, we are having 8, that is, then you have 2p6, we are remaining with, that should be 2, then we have 3s2. So that is the configuration. And how about, let's say, if we have something like, let's think of having, let's say, strontium, which is given as Sr, whose atomic number is given as 38. So how do you think we should have to accomplish that? Principle remains the same. We have 1s2, we have 2s2, we have 2p6, we have 3s2. How many electrons are here? We have 2, that is 4, and then plus 6, that is 10, and plus 1, okay, plus 2, that is 12. Then we'll have 3p6, we have them as should be 18. Then now we have 4s2, that is 20, which means we are still remaining with 28, should be 18 rather. Then you have 3d10, we are remaining with 8, and 4p6, we are remaining with 2, and 5s2 will be that one. So this is what you call as the electron configuration for that one. And also try to have the electron configuration for the following elements. Let's say if we have the rubidium, let's say rubidium, which is given as Rb, and our Wolf's atomic number is given as 37. And also let's have the, we have cesium, which is given as Cs, that is given as 52 as the atomic number. Try to have that one. And let's say barium, which is 56. And I also try to have the configuration for, let's say, beryllium, which is given as Be, that is 4. And how about, let's say, we should have something about zirconium, that is Cr, that is given as 40. So try to have the configuration using the Spdf notation in that way. And also let's think of having, let's say, Rf, which is 104. How should you have the configuration for that one? So that's how you start to understand about the electron configuration using the Spdf notation. And sometimes using the electron configuration using the Spdf notation, you can be able to have the, let's say, the group or actual group number of that particular element. You can have the group, you can have the period, and we can also be able to have the classes, the classification of that particular element, and we can also have to, we can also be able to identify that particular element. So here's the question for you: how can you be able to use the configuration using Spdf notation to classify, actually to group the element, to have the period of the element, to classify the element, and also to identify the element? So I want to see the responses in the comment section below. So that's how you start to understand about the electron configuration using Spdf notation, just for the open case. Thank you.